Hello, so today we are going to solve this problem called product of array except self. And the problem says we have an array of numbers and where n, so this problem is basically day 15 of the Leetcode 30-day challenge. So we have an array of n integers and we want to return an output such that for this output array, element at position I is the product of all the elements in the original array except the element at that position, right? So for example here, 1 is the product of all of these. 2 is the product of 3, 4, and 1, so we don't include the element itself. And it's guaranteed that the product of the elements of any prefix or suffix of the array fits in 32-bit integer. That's probably won't matter much for Python, and we want to solve it without division, right? Because division would be pretty easy, right? Because we'll just take the entire product and every time just divide by the element. And then a follow-up is if we can solve it with constant space. Okay, so one simple brute force solution would be to just create this output array, and then for each element just go over and skip the element itself, right? That would be really easy, right? But that would be O(n) squared, right? Because we'll go through all the elements and then for each one we'll do O(n). Another way we could do this is we wanna get the product of the left, like the elements on the left of I and the elements to the right of I. And we wanna multiply them and then get the result, right? So we know we need left here. So let's say for 1, left is still 1, right? And right is the entire all the elements except 1. So how can we do it in a way that is not, so what we are looking for is O(n) without division, right? Let's explore it a little bit on the terminal here. Okay, so let's say we have an array like this. How can we, so if we have a left element, right, so that starts out at 1 and the right product that starts out as 1, right? So for 1 we definitely need all of them, right? But can we like put the element in the position Okay, let's try to solve it with brute force, and then from there we can try to optimize with this solution here. So the brute force solution would be just go through the numbers, right? The ranges. So we get n equal to the length of numbers, and then we'll put n here. And then from there, what we need is we need an output, right? So let's call it res, right? So let's start out with 1, 4, since it's the product, so at least it's 1. Range of n, right? And so here we will need to go through j in range of n, and then if I is different than j, then we will say res at position I is multiply that with position j, and then at the end return res, right? So this is pretty straightforward solution. Okay, so you can see it fails with time limit exceeded, right? So what if we had a left that starts out as 1 and the right that starts out as 1? So what would we put in res here? So what we ideally want is to be able to say res of I equal to left multiplied by right. Maybe we could have left and right be arrays, right? So what if we had these be in a similar way be arrays, right? And then calculate them independently, right? So left of I here would be basically left of I minus 1. So multiplied by, so the element at position multiplied by nums for I minus 1. That way we start from 1 here. So that way left of 1 is left 0, which is 1 multiplied by a number as 0. So it's just an element before the last, just before the current position I, right? And then, so now we could, yep, I think an array would work. And then we could do a similar thing for the right array. But for the right array, we should probably start from the end, right? And we want to decrement and move until we reach 0. And then for the right array, what we want is also on the right, the product on the right, except the last element. So, except the element at position I. So what we want to do there is right plus 1, right? I plus 1, and then multiply that by a number at position I plus 1. And so here, we need to start from n minus 2, so that we get here right of n minus 1, which would be 1, multiplied by number at position n minus 1. And we'll keep doing that as we go along. And now for result, we could just say for I in range of n, res at I is just left at position I, multiplied by right at position I. And then we could, at the end, just return res. So if I run this, submit. Okay, so it's accepted. Yeah, cool. So one thing here is I'm still not using like constant space, like they said here, but we are doing it in O of n time, because this is O of n, this is O of n, this is O of n. So overall, it's kind of O of 3n. So that's O of n. So how can we make it use constant space without the follow-up here says that the res here doesn't count as constant space. So I'm thinking maybe we could just have one variable for left, and then we could just use res as, or maybe a variable for right, and maybe use res as just the left position for the left element for I, and then at the end we could just multiply by the element, multiply by right? So what if we made res be this, right? So now using extra space, right? And then we just did this loop for right product. And so this would be just the previous value of right. And now we could just take res I and multiply it by right. That would technically work. Okay, no, it doesn't. It's, yeah, gives a bunch of ones. Oh, I see. So right is actually still an array here. That's not what I want. I want it to be an element. And we don't need left anymore. Okay, so that works, great. So now we are using, well, a little bit constant space, but not really, because we are using this array. But yeah, that's what the problem asks, is no other extra space apart from this result array. And we wanna, and we are using this variable, but that doesn't count, that's O1. And in terms of time complexity, we have only 2 for loops, so it's O1 time. Yeah, I think that's it for this problem. Thanks for watching and see you on the next one.